This is a Baromix cement mixer manufactured in the late 1980s. I recently purchased this one on eBay for £150, and the reason why I was so drawn to it was because it already was in quite good shape despite looking very rusty. The gearbox features gears made from solid bronze and high grade steel, and it's powered by a 3 horsepower industrial commercial Briggs & Stratton engine which is renowned for reliability. Looking inside the drum, you can see that it has been well respected throughout its life, but sadly in more recent years it has been left outside, giving it this very crusty and flaky look. So please join me in restoring the cement mixer to its former glory, just like it was when it came out of the factory in 1988. My first job is to establish whether or not this machine is actually going to run. Firstly, you can see quite a significant amount of oil has leaked out of the drain plug on the engine. However, it looks like there is actually still enough in the engine just to give it a quick test. It's good to see the engine does still have an air filter. It's amazing how many people will actually just remove the air filter and run it without. Bizarrely, in the air filter tray here, there is what looks to be, and what smells like, penetrating oil. So that's a bit of a mystery. Just going to get that cleaned out of there. As I discovered a minute ago, the throttle doesn't seem to move that well, so I'm just going to free it off with a wire brush and a bit of penetrating oil. After working the lever backwards and forwards about 100 times, it moves freely now. Before I attempt to start up the engine, I have one last crucial check, and that is the fuel tank. Looking inside, it's actually surprisingly quite clean and rust free. This is a job for a paper towel and a set of long pliers. With the gummy old fuel residue removed, compressed air is used to do the final cleaning. I'm just using some regular unleaded for this test, but I think once the project is finished, I'll be using some Aspen. There was quite a bit of soot that came flying out of the muffler when I first started it, but it is smoking, so I'm not surprised that there's a lot of soot that has collected in there. So I'm just going to run it for a few minutes to see if this smoke does clear, but it is so good to see that it actually does run and the gearbox is fully working, so this is very promising for this project. After 15 minutes the smoke didn't fully clear, but it did improve massively, so this is looking very promising for the engine. It's now time to disassemble the entire cement mixer. Unfortunately, this aluminium pulley was very stuck, and if I was to fit a puller directly onto it, it would have just cracked and broken the softer metal. So I decided to quickly fabricate this U-shaped plate so that I could pull onto that instead of directly onto the pulley. And it worked. It's a very simple design, but that's all it needs to be sometimes. As this machine is going to be sandblasted, primed and powder coated, just like all my restorations, I do need to clean off all the oil. Luckily the stand doesn't really have too much cement on it, obviously there's some, but that should be okay for the sandblaster. And there we have it, there really aren't that many components. The next time we see these they will have been sandblasted, primed and powder coated. Yeah, there is a bit of pitting here and there. But I really am not a fan of using loads and loads of filler. It's okay on one small area, but when it's the whole thing, in my opinion, it's best just to leave it in the original condition, or if it's a smaller part, remake it. After doing a bit of research, I managed to get my hands on an original sales brochure of their full range. Baromix was a well-known British manufacturer of cement mixers and power barrows for decades. The factory was located at Birch Abbey Works in Ulster, where they produced petrol, diesel and electric mixers. During the 1970s and 80s, the iconic blue mixer was a common sight across many construction projects. Sadly, despite doing extensive research, I couldn't find any photos of the factory. But using Google Earth, I did manage to find on a late 90s satellite view, the factory still standing. I can't confirm if the entire site was just solely used by Baromix, however going back to an ordnance survey from 1971, there is an egg packing station on the southeastern side of the site. If you know much more about the history of this place then please do comment down below, I would love to hear from you. And as I got carried away with my research, as I always do, I discovered that in 1946 the site was being used as a needleworks, and before then in 1905, a cycle works. Anyway, back to Baromix. I'm probably going back a bit too far into history. At this rate I'm going to rediscover the dinosaurs. In 2002, Baromix was acquired by the French industrial conglomerate Oltrad. The acquisition was part of Oltrad's strategy to expand its presence in the UK market. In December 2002, an archaeological evaluation was carried out on the site, where extensive evidence of Roman activity was recorded. At some stage between 2003 and 2005, the factory was demolished to make way for residential housing. By 2008, the construction of the new housing estate was completed. I reached out to Oltrad and they very kindly gave me some more information about what happened after the independent Baromix closed down. So a big thank you to them. They told me that the Oltrad Baromix continued manufacturing from their nearby facility until early 2009. Between February and May, they had a team working on moving approximately 25 truckloads of goods and parts to their site in Sheen, Derbyshire. Their site in Ulster finally closed on May the 8th, 2009, officially marking the end of the Baromix production in Ulster. Today, Oltrad is one of the leading providers of construction and industrial equipment worldwide. The Baromix name was retained for the Baromix Commodore, still in production to this day. The Commodore is now manufactured in the Oltrad Bell Group factory, but I just love that they have kept the name. As with all my restorations, learning a little bit more about the history of the company means so much, and it just gives me so much enthusiasm to return it to its former glory. You just can't beat the satisfaction of turning something that could have been scrapped into something which is just starting the next chapter of its life. Whilst I wait for all the components to be sandblasted and powder coated, I'm going to restore the engine and gearbox, starting with the Briggs & Stratton engine. On so many of these old machines, the pulleys are stuck to the shafts, so I'm using heat and a hydraulic puller to remove this one. It's always nerve-wracking pulling on an aluminium pulley because you just know that you could crack it or even just break it in half. Let's just get these cobwebs removed. When these old machines aren't used, they always become a home to somebody, spiders or mice. The engine will now be disassembled, starting with the air filter, muffler, carburetor and fuel tank. Now I haven't actually drained the oil yet, and the reason why is because I wanted to inspect it properly on the workbench. So let's remove the recess plug, which has an Allen head. And there we go, how delightful. It looks like tar, or maybe bitumen or something like that. This engine has certainly not seen fresh oil for quite some time. But on the plus side, I can't actually see any glitter in it. You can see little air bubbles, but no metal filings. Next we have the ignition coil, starter clutch and flywheel. Now we know the engine has spark, but let's have a quick look at the spark plug. There is some carbon, but it's not excessive, it's not super crusty. So that does make me think that the engine doesn't really burn oil too badly, it's just it hasn't run for so long. Here's the true test, removing the head and looking inside the cylinder bore. So the head itself does have carbon on it, but it's not excessive, it's just pretty normal for an engine like this. As for the cylinder bore, it's an unfortunate spider there, but again, it's just the usual crusty carbony look that these small engines get. The cylinder wall looks lovely, you can still see the cross hatching from the factory. And we do have a bit of crust on the valves. The engine disassembly can continue, and next we're going to be going inside the engine to remove all of the internal components. Ah, lovely. The sludge has been revealed. Because this engine is such a high quality industrial and commercial engine, it does have the ball bearing instead of just the plain bearing on the crankshaft. Because of this, the disassembly is slightly different to normal. I have to remove the connecting rod first so that we can remove the camshaft and the crankshaft together. Usually you just remove the camshaft. Here is one half of the big end, and that also looks to be in very good condition. The piston can now slide out of the cylinder, and it looks to be, just like all the other components, in fairly good condition. And I can imagine this cement mixer has done quite a lot of hours. They do tend to just sit on a work site, idling away for quite some time. Now for the crankshaft and camshaft. And the push rods, of course, that always fall out. After a quick inspection, both the camshaft and the crankshaft are deemed to be perfectly reusable. Next, the ball bearing needs to be pressed off the end of the crankshaft. We're almost there, only the valves are left to be removed. To remove the valves, a valve spring compressor is used. This is necessary to remove the retainer from the valve stem to release the valve from the engine. The exhaust valve on this engine uses the pin type retainer, which Briggs & Stratton actually moved away from many years ago. It's a very simple idea, and to be honest, I quite like it. The intake valve has the circular type retainer, and there's also the collar type, but this engine does not have one of those. This design is certainly the easiest to fit. As you can see, it just slots in. And if you've ever wondered how I remember where all the different parts go, well, I use an organiser. This is far better than just dumping all the bolts into one big box, because you know exactly where each one goes. We just have the two oil seals to remove from the crankcase and the crankcase cover, and that is the disassembly completed. With the crankcase decarbonised, I can now tape it all up, ready for sandblasting. Although some of the sandblasting media will always get inside, taping it up does still help a great deal. The engine crankcase is not the only component that needs to be sandblasted. We also need to do the carburetor and the fuel tank. For the time being, I'm only really targeting the fuel tank because that is going to be powder coated. The carburetor will be done later in the video. All the plastic components must be removed from the assembly, because this will be baked in an oven, and it probably won't end too well if I leave them attached. We're now ready for sandblasting. The engine components are ideal for my small powder coating setup. In case you're wondering what colour I'm painting these in, it's actually raspberry red. They then need to spend 10 to 15 minutes in the oven at 180 degrees Celsius. And as if by magic, they go all glossy. Whilst they cool down, I will continue working on the crankcase. As mentioned, some of the sandblasting media does get into areas where you really do not want it, so I'm just giving a preliminary clean in the holes where the drain plugs go, and also at the top of the engine where the valves go. The ultrasonic cleaner leaves everything visibly cleaner. There's a very sharp line there. It's now time to hone the cylinder bore. To do this, I'm going to be using a flex hone, or ball hone. The reason for honing the engine is to put a cross hatching into the bore. This will allow the new piston rings to seat. After honing, cleaning is imperative, otherwise you can actually destroy the engine when you first start it up. I'll be giving it a thorough clean again later with the ultrasonic cleaner, but I do have some more things to clean first, starting with the exhaust port. Sorry if that sound reminds you of being at the dentist. I know. Ugh. Next we need the valves again because they need to be lapped in. And the reason for doing this now is because we want to make sure we wash out all of the grinding compound from the exhaust ports. Otherwise, we could cause even more issues down the line. In case you have no idea what I'm doing here, basically it's to allow the valves to seal. We know when it's done because we can see two very nice shiny rims on both the seat and on the valve. With both the valves lapped, it is now time to give the crankcase a thorough clean. So to do this, I'm using my larger ultrasonic cleaner, and I've got some hot water mixed with some dish soap or washing up liquid, and it's just going to basically be given as long as possible to clean. We need to get all of the unwanted grit out of there. Jacuzzi! With the parts cleaner empty, wow, all of that came out of the crankcase and the crankcase cover. So now that we have a nice clean crankcase to work with, I am just going to check the original piston rings. They may well be in spec, but I'm going to change them anyway, because I always feel that if you're going to go this far, you might as well change the rings. So the top compression ring is 15 thousandths of an inch. That is within tolerance. The middle ring is 10 thousandths of an inch, also within spec. And the oil scraper ring is 17, which means that all three can be reused if I want to, but I don't. So what I'm doing here is I'm fitting the new one, and I'm going to measure the gap of the oil ring. The new oil ring is 5. And both the top and the middle compression rings were 6 thousandths of an inch. With the piston decarbonised, the rings can be fitted. Now before I can start to reassemble the engine, I need to fit a new bearing onto the crankshaft. So to do this, I'm going to submerge this new bearing into some engine oil and just very gently heat it. It doesn't want to be boiling, it just wants to be warm. That will allow the bearing to expand and it should just slide onto the shaft. After around a minute of heating, you can see the oil is definitely getting very thin and warm. So I can now remove the bearing, and it's amazing how easy it is to fit it onto the shaft. It literally just slides straight on. As soon as it cools, it will require a hydraulic press to remove it. The time has come to reassemble the engine, starting with a new oil seal. This is followed by the push rods, camshaft, crankshaft and the piston. Now, because the timing gear is covered by the new bearing, I've put a dab of orange paint on the timing tooth. Then the camshaft and the crankshaft are installed together in time. The rod bolts are torqued, and that concludes the internal assembly. I'm using some Permatex high-tack sealant on the gasket just to guarantee that we do have a leak-free reassembly. Before we can fit the cylinder head, we have the two valves to install. Now we're turning. The cylinder head needs to be sandblasted and then it can be refitted. We've reached the stage where the engine can be painted, and as you can see, I've taped over everything that doesn't want to be painted. I'm using a very high quality raspberry red. And whilst the engine dries, I can now start work on the carburettor. Now this carburettor did work fine, as we saw, but it's a bit grimy. So what I'm going to do is I'm going to submerge it in the ultrasonic cleaner to remove any unwanted grime on the exterior, then I can clean the internals properly. Being extra careful with this, very well taped, let's sandblast it. With the paint removed, I can now remove the diaphragm, spring and cap from inside the fuel pump, and then the inside can be cleaned with carburetor cleaner. Once cleaned, the fuel pump is rebuilt and the carburetor can be painted. I always prefer the appearance if you do not paint the mixture screw, so I was just using a standard screw to cover over the hole. The mixture screw is turned in fully and then turned out 1.5 turns. The carburetor can now be mounted back onto the fuel tank, and then the entire assembly can be fitted to the engine. Now we just have the final few components remaining, such as the flywheel, the ignition coil, and the recoil cover. The recoil does take a little bit of assembly, as it does consist of the main pulley and the spring. So once the spring is tensioned, it slots into a little groove in the cover, and then basically you tension the spring, lock it into position, and then insert the pull cord. The engine is really starting to take shape, but it's clearly missing some decals. Now you can't actually buy these decals anymore, so I'll have to remake them. Now I get loads of people asking me how I make my decals. Basically I use Affinity Designer, but you can also use Photoshop or anything like that. Then I send the documents off to a vinyl printing company to be printed, and then they send them back to me. Here is the final result. This one has been printed on silver vinyl. We're moving on to the finishing touches. So we've got the two plastic levers, the air filter box, and I did intend on reusing the top cover for the air filter, but it was much rustier than I anticipated, and as you can see, it does not look good at all. So after spending way too long considering what to do for the best, I decided just to go for the modern equivalent, which actually still looks quite good, the black plastic cover. We only have two components left to fit, the new muffler and the spark plug. The engine is finished, and I'm very happy with the result. So it's time to put the engine to one side because next we need to rebuild the gearbox. As we've already seen in the demonstration, the gearbox does work fine. However, it's old, it is leaking a bit, and it would just benefit from new seals and bearings. So that's what my plan is. I'm going to dismantle it, renew everything, and then reassemble it. This is worrying. Well, I knew it was leaking, but not that much. Let's take a closer look inside. Well, there's something which once resembled oil, but now it's just a gooey old mess, filled with shavings of bronze gear. So I'll just press this top shaft out first, and then we can press the main shaft out. That way I can get hold of the bronze gear to inspect it closely. Yeah, so this is quite worn. I think I'm going to have to try and get hold of a new one. I believe Ultrad do actually sell them, which is amazing. The large shaft is in good condition. All that's left are the two large bearings that need to be pressed out. This This gearbox is experiencing something which it probably never thought it would do, if it was conscious of life. A bath! A nice, warm, soapy bath. Then it's going to be sandblasted and lacquered. What a pampered gearbox. It already looks much better after its wash, but I know we can make it look even better. One final clean just to make sure there's no grit left inside it. What a vast improvement. Now one final step, the lacquering. The reason for doing this is not only to give it a much nicer appearance, but also to prevent oxidation in the future. The 3 plates are sandblasted and primed, and then later on they'll be painted with gloss black paint. We're ready for reassembly, and if you look at the bottom right, I did manage to get hold of a new bronze gear. We also have new seals, bearings, and at the back we do have the pampered gear case. Let the reassembly begin. You can see how worn the original gear was when you put it next to the new one. New gaskets are not available anymore, so I'll be making my own using the plates as a template. I'm covering the keyway with some masking tape just so I don't cut the new seal, which is inserted in the circular plate. One last step, the oil, something this gearbox has not seen for a very long time. Now there's no sight glass, so you can't actually see how full it is, but it does tell you the oil level, so I'm using a bore scope to see exactly where the oil level is. Referencing the bolt to the level mark, I can see that it can take a little bit more. Perfect. The gearbox is finished, and look what's returned! We have got all of the other parts back from sandblasting and powder coating, and they look amazing. So we have just one more reassembly to do, and that is of the main unit. Let's get it done. As cement mixers are not known for their high mileage, the wheels are in really good condition, they just need a good clean. It's always fun looking at a bubble, especially in 4K. All the fascinating rainbow effects. Sorry to burst your bubble, but we need to continue. It's amazing what a bit of soap and water can do. Just like I did with the engine, I'm now remaking the decals for the machine. And now we're getting to the exciting part. We're almost ready to start the engine. But first we need to put oil in, petrol, and I'm actually going to be demonstrating this properly by putting some cement in. So we're going to mix some cement and make a bit of concrete. We have one final finishing touch, the rubber grips for the handles. And the project is finished. The Baromix is ready to mix. So what I'm doing here is I'm filling up this ballast box with concrete, really just so I can lift more weight with my front loader on the compact tractor. The ballast box is half full, which is actually ideal because then I can still use it to carry straps and chains and all that sort of stuff. But if I ever do want to fill it up to the top in the future, well, I have a cement mixer. I always get comments on my restoration videos saying, how can you make it dirty after putting all that work into it? Well, I actually do clean everything after using them, and I try and make them spotless again. Just doing a few finishing touches on the concrete, but that really does conclude this project. I'll have a full-length video of the ballast box project on my other channel, Daggerwin. Thank you for watching, and I'll see you in the next restoration. Please remember to like and subscribe.